Hi, my name is Muhammad Tariq, and in this lecture, we will see the delete operation in AVL trees. How delete operation can affect the balancing factor of AVL trees and how we can rebalance. We have seen the insertion operation, and after every insert, we calculate the balance factor, and thus that balance factor helps us in keeping the tree balanced. So now in delete operation, how that balance can be kept, we will see this in this lecture. Now let's quickly recap how we perform the delete operation in binary search tree. So we have a tree here. Let me draw a sample tree here with some nodes. I have 5 here, and on the right hand side I have 15, and as a child of 5 I have 2, I have 3, and here I have 9, and let's say I have 12, and on the right hand side I have 20, and on the left hand side of 20 I have 17, and on the right hand side of 20 I have 30. Now let's suppose I want to delete the node number 15. I want to delete node number 15. So what I will do, I will traverse on the right hand side first, and then I will go all the way to the left hand side. For example, if we have some nodes attached to 17, something like this, then what I would do, I will iterate all the way. I will iterate all the way here, and then I will choose the last node. I will choose the last node to be replaced for 15. So the actual process is I will replace this node with this, right? I will replace whatever is in the last node, and sorry, I will replace 15 with whatever is there in the last node, right? So this is the in order successor logic. So in this case, we have 17. So we will simply replace this with 17, and we will remove 17 from here, right? Okay, now this tree is still very balanced. Now let's remove 12. Let's remove 12. There is no node. 12 is a leaf node, so it's very easy to remove 12. We need not to make any adjustments. Now if we calculate the balance factor from here, so the balance factor of 30 is 0, the balance factor of 20 is -1, the balance factor of 17 is -2, the balance factor of 10 is 0 because we have 3 levels on the left hand side and 3 levels on the right hand side. The balance factor of 3 is 0, the balance factor of 2 is -1, the balance factor of 5 is 2, -1 is 1, and the balance factor of 9 is 0. As you can see here, the balance factor of 17 is -2, which is not within the range of the acceptable balance factors. So we have -1, 0, and 1. This is the acceptable range. Every node should be within this range. Okay. So now we need to apply the rotation to balance this node. And as you can see here, we can apply RR rotation. Okay, because both the nodes are on the right hand side. So let's apply the RR rotation, and when we apply the RR rotation, also remove the balance factors from here. When we apply the RR rotation, we know what happens is we make the disturbed node as A, and we make the child of A as B. So we will make B as a parent of A. So it will be something like this. Here we will have 20. Here we will have 17. And here we will have 30, right? Now if we calculate the balance factor, the balance factor of 17 is 0, the balance factor of 30 is 0, and the balance factor of 20 is also 0. But the balance factor of 10 is 2 minus 3 is -1. We need not to change any balance factor of the right subtree nodes because we did not change anything here. So it's now it's balanced tree. It's the AVL tree and every node within the acceptable range. Now we have a tree something like this. Now this tree we have, and it is an balanced tree also. Now try to delete some nodes from this and then see what happens. So let's first delete node number 9. If we delete node number 9, and now let's calculate the balance factor now. So the balance factor of 3 is 0. The balance factor of 2 is -1. The balance factor of 5 is 2 minus 0 is 2. The balance factor of 10 is 3, 1, 2, 3, 4. So 3 minus 4 is -1. So as you can see here, and these balance factors, okay, so the balance factor of 13 is 0, balance factor of 33 is 0, balance factor of 30 is -1, 18 is 0, 11 is 0, balance factor of -1, 1 minus 2 is -1, 1 minus 2 is -1, and we have 1, 2, 3, 1, 2, 3, 17 is 0. So the balance factor of node number 5 is 2, which is not good. So we need to apply the rotation, and what rotation we would apply? We would apply the LR rotation, right? As you can see here, one node is on the left hand side and then one is on the right hand side. We will apply the LR rotation. So the first we will mark A to the node which has the disturbed balance factor, and then we will mark B and C to the child of A. So in LR rotation or in RL rotation, we make C as a parent of A and B, right? So it will be something like this. We will have C here. So we will write 3 here. Okay. And then we will have 5 here. Okay. And we will remove this. Now, if we recalculate the balance factor, we will have 0, 0, and 0. And now we have 2 minus 1, 2, 3, 4. We have 4 levels. Okay. 1, 2, 3, 4. So, and we have 2 levels here. 2 minus 4 is -2. So the balance factor of node 10 has disturbed. Now, what we will do, how we will balance this tree? We know we apply rotation. Now, to apply rotation, which side we will choose? Should we go towards the left hand side or should we go towards the right hand side? To determine this, we have some rules defined and we will follow those rules to balance the tree. Let's look at the rules. So the first point is, unlike insertions, one rotation may not be enough to restore balance to the tree. If this is the case, then locate the next node where the balance factor has disturbed. Now, if A's balance factor is positive, now here if we see, the A is this one. The node A is 10 because this node's balance factor has disturbed. Now, if it says if A's factor is positive, but A is not positive, so we have A is negative. If A's balance factor is negative, so if A's balance factor is negative, what we will do? If B right subtree height is larger than B's left subtree. So now if we look at here, what we have B, this is B. Okay, this is B. Now we will check the right subtree height is larger or the left subtree height. So on the right hand side, we have 1, 2, and 3. On the left hand side, we have 1, 2, 3. So the height of the right subtree and the left subtree is actually balanced, is actually equal. So it says if B's right subtree height is larger than B's left subtree height, then perform single left rotation or left rotation. In the second case is if B's right subtree height is smaller than the B's left subtree height, then perform single left rotation. Sorry, right left rotation. But in our case, we have the height equal. Then what we can do, you can perform either rotation, right? We can perform either rotation. Now, here we need to choose either we should go on the right hand side of the B or on the left hand side of the B. So we have the equal nodes. We have equal nodes on both on the right hand side and the left hand side. So we will go for we will go for the right hand side, right. So we will make 20 as C. Now let's apply the rotation, and we will make B as the parent, and A and B will become its child, right. We have 17. Okay, we have 17, and on the left hand side we have 10, and on the right hand side we have 20. Okay, now look very carefully that how we will balance this, right. For this whole section, this will remain the same. Okay, this will remain the same. So let me add this here. So we have 18. Okay, we have 18, we have 30. Okay, and we have 33. Okay, now what about this section? What about uh, this section? Okay, what about this section? For subtree, this subtree will be attached to the right hand side of 10. Okay, this will be attached to the right hand side of 10, and this will be 12 here, and all the children's will remain same, will be on their own position. Okay, and here 13. And now let's take this one. So this is on the right hand side, this is on the sorry, this is on the left hand side of 10. So this will remain the same, this will remain here 3. Okay, 3, and then we have 2, and then we have 5. So this tree is a balanced tree now. This is a balanced AVL tree. Now if we calculate the balance factor of 3 is 0, the balance factor of 33 is 0, 11 is 0, 5 is 0, and 2 is 0. So these all are leaf nodes. So the balance factor of 3 is also 0. The balance factor of 10 is 1, 2, 1, 2, 3. So it's minus 1. Okay. The balance factor of 17 is 1, 2, 3, 4. 1, 2, 3. 4 minus 3 is 1. The balance factor of 20 is 1 minus 2 is minus 1. The balance factor of 3 is 0 minus 1 is minus 1. And 18 is 0. The balance factor of 12 is 1 minus 2 is minus 1. And 1 minus 0 is 1. So as you can see, we have balanced the tree using double rotations. We did 2 rotations, right? Or what were those 2 rotations? First, we balanced this section after deleting 9. First, we deleted 9. Okay, and after this, when we calculated the balance factor, the balance factor of node number 10 become disturbed. So to balance node number 10, we applied another rotation. The second time we applied rotation, and we had 2 choices there. Either we could choose this path, okay, this path. Okay, we could have choose RL, or we could have choose LL. Okay, sorry, RR. This is RR. This is on right hand side. RR. So we chose RR rotation, and when we applied the RR rotation, so we got the resultant like this. So this is how we can implement the rotations, and when we apply the delete operation, we need to take care of the unbalanced nodes, and then we apply rotations to balance the tree. Hope this would be helpful for you, and I will see you in the next lecture. Thank you.